We're solving problem 13 from the 2022 F equals MA. Exam B. A ballistic pendulum is designed as shown below. A uniform ball of mass M and radius R is attached to a massless rigid rod so that its center is a distance L from the ceiling. The ball is a small tunnel hollowed out. A small block of mass M and speed V goes into the tunnel and collides at the center of the ball perfectly and inelastically. Subsequently, to what maximum height does the block rise? Here is these are two depictions of what's going to happen. This is before the block hits, and this is after. And this arrow represents the angular momentum omega going this way, turning it up. It then shows that the initial length, called I, is equal to m or L. No, VL, velocity. And then the final length is equal to inertia times omega, where inertia for this problem is equal to the sum of the inertia of the ball and the inertia of the block, which are the ball is 2/5 times m or squared plus ml L squared. Then the block is simply ml squared. You could simplify this down by removing a 2 and a m. This is r squared over 5 plus L squared. Simply that. So we have an equation for inertia now. And this is pretty handy because the kinetic energy at this point is equal to L initial squared over 2I, and this is final squared over 2 times the inertia. So since you set these equal to each other, well, you can use this one. So the initial is when you square that, m squared v squared L squared over 2m times r squared over 5 plus L squared. You can divide both sides by m. This becomes an m, and then cross out the L. When you divide both sides by L, you get that k is equal to m v squared. And then the denominator, this is a 4, because 2 times 2 is 4. This becomes 4 r squared over 5 L squared plus 1. So now we have an equation for the kinetic energy. And you want to conserve forces in this second moment. You want to find the height. So in this second moment, where k is equal to u sub g, g is gravity, this becomes n v squared over 4 times r squared over 5 L squared plus 1. This is going to be equal to, what is u of g? U sub g, this is 2m times the height times gravity. These m's cancel out, so that's gone. And then divide both sides by 2, you're left with an 8. And then divide by g. So what you get for your answer h is v squared over 8g times 1 plus r squared over 5L squared. So that is our answer for this problem, where this is the height h, change in height.